Okay, coverage. We haven't talked about coverage yet. We've talked about tests, but what is it that you're measuring when you're trying to measure how good your test suite is? And so you can think about the question of coverage as really asking how much testing is enough. The way that it, I think, sadly used to be is, when it's time to ship, that's how much testing is enough because we don't want to slip the shipping date. I never really understood that, but a little bit better is there are a few very simple static measurements like the number of lines of tests divided by the number of lines of code. And I don't know if it would surprise you at this point or not, I hope not, that factor should be greater than 1. 1.5 is not a bad target. So yes, that means that your app actually has more total lines of tests than it has lines of code. And in fact, for production systems that are sort of in mission critical applications, it can be much higher. So maybe a better question to ask is, how do you know how thorough your testing is? What are the ways that you measure the thoroughness of testing? There are some formal methods for sort of analyzing what parts of the code possibly could be reached. There's coverage measurement, and we are going to focus on coverage measurement somewhat more, but formal methods and design for correctness and things like that are starting to get more traction. So let's start with the idea of coverage. It's actually not really obvious what 100% coverage means. Here's a pretty simple function, actually two simple functions, I suppose, foo and bar, because those are the canonical function names. And so the question is, what does it mean to achieve 100% test coverage for this? Okay, well, let's unpack that because this is going to get fun and hairy fast. You're right, by the way. It means I would like to cover every part of my code. As it turns out, though, it's a little bit tricky to nail down exactly what that is. So there's a few sort of levels of testing that are kind of well-defined. The most basic one is you call every method. Okay, well, who cares about that? So, if your test suite calls foo at least once and calls bar at least once, you've achieved 100% coverage at the S0 level, but that's not terribly ambitious. A little better is to say you call every method from every call site. So for example, in this case, the bar method could be called from this clause, or it could be called from this clause. So to achieve S1 coverage, you have to call it at least once from each of those places. But, better than this is to say, look, did I at least run every line of code? So that's what we'd call C0 coverage. Every line of your app is touched at some point by something in your test suite. But even that is not necessarily always the right measurement because, for example, C1 coverage says every branch is taken in both directions. Now you would think, well, wait a minute, if every line of my code is touched, doesn't that mean that every branch had to be, at some point taken in both directions? Not necessarily, because imagine a case where in line 3, X is true here, and so we execute this line. But in this case, Y and Z is false. This line has been touched. So C0 coverage has been achieved. But the then clause of this if has not been touched. So C1 coverage hasn't been increased. So every line being touched and every branch being taken in both directions are not necessarily the same thing all the time. You can go beyond that as well, which is C1 plus decision coverage, which means every sub-expression in the conditional is evaluated to both true and false. So for example, in this case, we have a conditional that has two terms, Y and Z. C1 plus decision coverage means that this line has been executed for at least one true value and at least one false value of Y, and at least one true value and at least one false value of Z. So basically all of the sub-expressions within a conditional get exercised in each Boolean sense. And then even more ambitious than that is every possible path through the code, which is actually quite difficult to achieve, and there isn't really full agreement on how much more valuable that is. Remember that there's testing all the code you have and finding bugs in the code you have. The best test cases will fail to test the code you don't have. So if there's a bug in your program, not because you have code that works incorrectly, but because there is some case that you didn't think of and there is no code for it, you can't really expect that even 100% coverage will find that. So there isn't really agreement on how much more value there is to trying to achieve C2 coverage. In practice, the coverage tools that we use day to day are somewhere in the C0, C1 range. I believe SimpleCov gives you either C0 or C1, probably C1. So, we want to cover all of our code. And by the way, when we say every line of the code is touched, remember that if you have a set of Cucumber scenarios and you have a set of RSpec tests, they can both contribute to coverage. So a good coverage testing tool will actually look at all of the different kinds of tests you run and combine the coverage information from them. So there might be some lines that are covered by a scenario, but they're not also redundantly covered by specs or vice versa. So, where does this leave us in thinking about testing? We've seen everything in the range from unit tests, which are focused on one method or one class, function, so model specs would be an example. They're sort of exercising one or a couple of methods just within a model class. We've looked at functional tests, like our request spec, where you're calling a controller method, but it might have to reach out and touch a few other components in order to do its work. And then we've looked at integration level tests, where you're talking about multiple requests in a work session, like a Cucumber scenario would be. So where you place tests on the spectrum affects a number of things. Unit tests tend to run a lot faster. So it's, in terms of sort of tickling a lot of little corner cases in the code, they're sort of much more efficient to do that with unit tests than to try to do them with scenarios. So sometimes there'll be sad paths in a scenario that really depend on minor variations in things, like if the user mistypes something or if they try to leave something blank on a form. And it feels like killing ants with a pile driver to have separate scenarios for all that. So you might have a scenario that covers a couple of the important happy and sad paths, and then a bunch of specs that sort of try to clean out the corners in between. So why is it that things like specs can have finer resolution? As we've seen, one of the reasons is that they can make generous use of different kinds of doubles, right? To fake out things to make the code go a certain way that would be awkward to do if you were trying to do it from the level of a scenario. The downside of that is because you're faking out some of these interfaces to other classes or to other objects, those kinds of tests do not test whether the interfaces are sane. So if APIs change out from under you, your unit test probably will miss that because they're specifically designed to isolate the behavior of the piece being tested from those other interfaces, whereas things like module tests or integration tests will exercise them because they use much fewer or many fewer stunt doubles and mocks, and they will sometimes find those kinds of bugs that your unit test would miss. It's a little bit easy to go overboard, stubbing and mocking everything, and then realizing that you don't have tests that actually check whether the parts talk to each other in the right way. Similarly, for those same reasons, if you're trying to increase your coverage, especially of hard-to-reach parts in the code, you're more likely to be successful doing that by adding specs that target some of those hard-to-reach cases than by trying to run more scenarios. So there's always going to be a balance of different kinds of test cases, which means, instead of going to extremes, which are, one extreme is like, oh, I tried a couple of things manually, it looks good. Another extreme is until it's 100% covered and everything is green, then we're not ready to release it. Instead, this is, again, taste is hard earned, but it's really important. Use coverage to identify parts of the code that are clearly under-tested and focus your attention there. And by the way, you may find over time that some of your unit tests basically become obsolete. There are testing behaviors that no longer need to be tested separately because other tests cover them. There's nothing that says that a test that enters your test suite has to live there forever. Similarly, you shouldn't sort of overly focus on unit tests just because they're more thorough, nor should you focus exclusively on integration tests because they're more realistic since you're stubbing fewer things. The fact is that each of those kinds of tests can find bugs that are missed by the others. So coverage is your friend, right? Getting good coverage information serves as a guide to tell you which parts of the app are under exercise. And having a good test suite, it's a thing of joy and beauty. When you push your code, your test suite runs and everything is green and you didn't break anything, that's a nice feeling to have. Or as we'll talk about when we talk about bug fixing, when you do find a bug and you create a test that fails because of the bug, that's a wonderful moment because now you know how to fix it. You can get the bug to reproduce at will. And once you've checked in that test, you know that if that bug ever tries to come back, it'll be quickly detected.